press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the next problem in fundamental principle of counting. So I think up to fourth problem we finish up in the exercise 7.1. The next fifth problem. Fifth problem. How many 5-digit telephone, how many 5-digit telephone numbers can be constructed using the digits 0 to 9, using the digits 0 to 9 if each number starts with 67 and no digit appears more than once. No digit appears more than once. See the first problem very carefully. What he asked, how many 5-digit telephone numbers can be constructed using the digits 0 to 9. How many 5-digit telephone numbers can be constructed using the digit 0 to 9? One more condition. If each number starts with 67, so we write first 5 box. 5-digit number, correct? 1, 2, 3, 4, 5. Correct? 5-digit telephone numbers. So each number starts with 67. In the first place, I filled 6 number. On the second place, I filled the number 7 because he has given each number starts with 67. So from 0 to 9, 10 digits, 10 numbers are there. Correct? From 0 to 9, 10 numbers are there. Among 10 numbers, I use 2 numbers already. What are those? 6 and 7. Remaining box, how we can fill it? One more condition he has given. No digit appears more than once. No digit appears more than once. It means what? Repetition of the digit is not allowed. This is the condition. Repetition of the digit is not allowed. Means third box we can fill in how many ways? 8 ways, because we use 2 numbers already. What are those numbers? 6 and 7. Okay, so third box we can fill in how many ways? 8 ways. Fourth box we can fill in how many ways? 7 ways. Correct? And which one? Fifth box we can fill in how many ways? 6 ways. We can fill in how many ways? 6 ways. For 5-digit number, first, second, third, fourth, fifth. Second is depend upon first, third is depend upon second and first, fourth is depend upon 3, 2, 1, fifth is depend upon 4, 3, 2, 1. Okay, all the events are not independent, they are dependent. That means we apply fundamental principle of counting. Correct? Multiplication rule. According to the multiplication rule, total number of 5-digit numbers. Total number of 5-digit numbers is nothing but 8 into 7 into 6. 8 into 7 into 6. How much? 8 into 7 into 6. 336. 336. This is what? The concept of the given problem. Carefully you have to observe. We write the answer. We write the answer. Okay, solution. Given 10-digit numbers, that is from 0 to 9. 0 to 9. First box can be filled only 6 number, 6 digit, 6 number. Second box can be filled only which one? 7 number. 7 number. Only these two numbers we can fill in first and second box. Since repetition of the digit is not allowed, since repetition of the digit is not allowed, third, fourth and fifth boxes can be filled in how many ways? 8, 7 and 6 ways. 8, 7 and 6 ways. According to right here, according to fundamental principle of counting or what? Multiplication rule, total number of 5-digit telephone numbers, total number of 5-digit telephone numbers is equal to 8 into 7 into 6, 336. 336. This is the answer for this problem. Carefully observe. Next problem. Sixth problem. Given 5 flags of different colors how many different signals, how many different signals can be generated, each signal requires the use of two flags, one below the other. See the problem. This is the last column in the exercise 7.1. See, very simple problem. Given 5 flags, he has given 5 flags of different colors. How many different signals can be generated? Each signal requires the use of two flags, one below the other. Each signal requires the use of two flags, one below the other. This is one first place, this is one second place. First place, second place, one below the other. See how many different signals. This is very important. How many different signals? That means repetition of the flag is not allowed. So that means the first box, because he has given 5 different flags of different color, 5 flags of different colors, the first box can be filled in how many ways? 5 ways. Since repetition of the digit is not allowed, because he has given different signals, he wants different signals, repetition of the digit is not allowed. Second place we can fill in how many ways? 4 ways. Second place we can fill in how many ways? 4 ways. To generate signal, we need first and second place, first box as well as second box. Means second box is completely depend upon first box. That means here we apply the fundamental principle of counting or else multiplication rule. According to the multiplication rule, total number of different signals of two flags is given by 5 into 4. How many ways? 20 ways. This is very simple question. How many ways? 20 ways. So this is the concept. Observe the concept first carefully and write your own method for this answer. Okay, for this one, answer. Solution. Given 5 flags of different colors. Correct? 5 flags of different colors. First box can be filled in 5 ways. Correct? First box can be filled in how many ways? 5 ways. Next one. Since repetition of the digit or else flag is not allowed, repetition of the digit is not allowed, second box can be filled in how many ways? 4 ways. Second box can be filled in how many ways? 4 ways. Okay. The next, according to fundamental principle of counting. According to fundamental principle of counting, total number of two flags signal is equal to 5 into 4, how many? 20. 5 into 4, how many? 20 ways. See this problem. This completes the 7.1 exercise. First you observe this problem. Very interesting problem. Very simple problem. Next problem. So this completes the 7.1 exercise. We solve worked example problems also. First example, problem 1. Find the number. Find the number of 4-letter code. Find the number of 4-letter words, not code, sorry, 4-letter words with R without meaning. With or without meaning, which can be formed, out of the letters of the word rose. Where the repetition of the letter is not allowed. Repetition of the letter is not allowed. This is the first word example problem. Very simple problem. See, find the number of 4-letter words. Find the number of 4-letter words. We have to arrange 4-letter words with or without meaning. If they given meaning, okay, no problem. If they are not given meaning, that also no problem. Which can be formed out of the letter of the word rose. He has given rose. Rose contains 4 letters. Correct? Rose contains how many letters? 4 letters. Where, one more condition, where repetition of the letter is not allowed, means repetition of the digit is not allowed. So how many letters? 4 letters. We write 4 box. I write here 4 box. Okay, this is the first place, second place, third place, fourth place. All these are all events. Second is depend upon first, third is depend upon second and first, fourth is depend upon third, second and one. So that means all the events are dependent to each other. So to find the total number, we apply fundamental principle of counting, correct? Or else multiplication rule. Okay. Rows contains how many letters? 4 letters. That means first box can be filled in how many ways? 4 ways. Since repetition of the letter is not allowed, repetition of the digit is not allowed, second box can be filled in how many ways? 3 ways. Following which? Third box we can fill in how many ways? 2 ways. And the fourth box we can fill in how many ways? 1 ways. By fundamental principle of counting, total number of ways means total number of 4 letters code. By 4 letters, by using the letter rows, 4 into 3 into 2 into 1. How much? 12, 24. The answer is 24. Very simple question. Okay. So this is the concept. We write the solutions. Solution right here. The word rose contains 4 letters. The word rose contains 4 letters. First box can be filled in how many ways? 4 ways. Correct? First box can be filled in how many ways? 4 ways. Since repetition of the digit is not allowed, repetition of the digit is not allowed, second box can be filled in how many ways? 3 ways. Third box can be filled in how many ways? 2 ways. Fourth box can be filled in 1 ways. According to fundamental principle of counting, total number of ways, 4 into 3 into 2 into 1, all into 2, 24. This is the answer. See this answer. So you can follow any another method also. You can write any other. This is my method. If you want, you can follow any another method also. Here, my intention is you have to understand the concept very carefully. That's all. See this concept. Very important problem for 2 mark questions. Next problem. Next worked example problem. Second worked example problem. Problem number 2. Given 4 flags of different colors. How many different signals can be generated if a signal requires the use of two flags, one below the other. This is just now we solved this problem in the exercise. One below the other. Just now we solved this problem. Yes, na? Same type of problem. Given 4 flags of different colors, how many different signals can be generated? Different signals means repetition of the digit is not allowed. 2 flag signals, correct? 2 flag signals. Upper box means first place and second place. Okay. So here given 4 different flags. First place we can fill in how many ways? 4 ways. Means first box we can fill in how many ways? 4 ways. Following which? Second box we can fill in how many ways? 3 ways. Why it is 3? Repetition of the digit is not allowed. Repetition of the flag is not allowed. So second is completely depend upon first box. So according to the fundamental principle of counting or multiplication rule, total number is 4 into 3. How many ways? 12 ways. Understand? Very simple problem. Okay. Solution. Given 4 flags of different colors. 4 flags of different colors. Okay. First box can be filled in how many ways? 4 ways. 4 ways. Since repetition of the digit means repetition of the flag is not allowed. Repetition of the flag is not allowed because he want different signals. Correct na? Different signals. Second box can be filled in how many ways? 3 ways. Correct? Second box can be filled in how many ways? 3 ways. According to fundamental principle of counting or else multiplication rule, total number of ways, nothing but 4 into 3. How many ways? 12 ways. Okay, same problem. Just now we discussed in the last problem of exercise 7.1. Same type of problem. Total number of different signals of 2 flags. Total number of different signals of 2 flags is 12. What my point? Next, work an example problem. See this problem first carefully. Third worked example problem. Third one. How many two digit even numbers? This is very important. How many two-digit even numbers can be formed from the digits from the digits 1, 2, 3, 4, 5, comma, if the digits can be repeated. If the digits can be repeated. If the digits can be repeated. See this problem? This type of problem also we discussed in the exercise 7.1. Okay. So, how many two-digit even numbers? Two-digit even numbers. The number must be even number. Can be formed from the digit 1, 2, 3, 4, 5. He has given. 5 numbers he has given. 5 numbers he has given. In that 5 numbers, 2 and 4 are even numbers. Okay. Two digit even number he wants. That means unit place must be even number only. Correct na? Unit place must be what? Even number only. Among these digits, these numbers, 2 and 4 are the even numbers. Total is 2. 2 even numbers are there. So that means unit place can be filled in how many ways? 2 ways. Because here we filled only either 2 or 4. Because we want what? Even number. We want even number. That's why we can fill either 2 or 4 in how many ways? 2 ways. Okay, that's over. Unit place is over. This I call it as event E1. And this I call it as event E2. Okay, one more here, observe here. If the digits can be repeated, he has given up to these problem, to this repetition is not allowed. For this problem, repetition is allowed. That means, so if I insert 2 here, the same number also I can insert in the 10th place also. If I insert 4 here, in the unit place, the same number I can insert in the 10th place also. So this can be filled in. Total number is 5. This can be filled in how many ways? 5 ways. E2 is completely depend upon E1. Yes, na? E2 is completely depend upon E1 according to the fundamental principle of counting or multiplication rule. Total number of ways is 5 into 2. How many ways? How many ways? 10 ways. 10 ways. This is the answer. We write the answer. This is our concept. Solution. Given digits are 1, 2, 3, 4 and 5. Total number of digits 5. Total number of digits is 5, correct? Next, even digits. Even digits are 2 and 4. Total number of even digits is 2. Total number of even digits is 2. Okay, then. So unit place can be filled in how many ways? 2 ways. Correct? Unit place can be filled in how many ways? 2 ways. Since he has given repetition of the digit is allowed. Repetition of the digit is allowed. 10th place can be filled in how many ways? 5 ways. 10th place can be filled in how many ways? 5 ways. I write here. Tenth place can be filled in how many ways? 5 ways. According to fundamental principle of counting, total number of ways 2 into 5, 10. 2 into 5, 10 ways. Understand? Observe this problem. Very important problem. Next, worked example. Fourth worked example problem. Find the number of different signals. Find the number of different signals that can be generated, that can be generated by arranging at least two flags in order, one below the other. One below the other on vertical star. If 5 different flags, 5 different flags are available, 5 different flags are available. This is very important problem. Say, observe here, observe this problem first carefully. Find the number of different signals that can be generated by arranging at least two flags. Minimum is 2. Okay, minimum required is 2, not less than 2. One below the other on a vertical star. What he has given? He has given 5 different flags. In that 5 different flags, we generate the signals. The signals contains, very important, the signals contains at least 2 flags. It may be 3 flags, it may be 4 flags, it may be 5 flags, it may be 6 plus. No. Why? Because the maximum flags available is 5, but not less than 2, not more than 5, not less than 2, not more than 5. Okay, see, observe here, very interesting problem. Solution. First we observe the concept. Okay, so what he has given? At least 2 flags, 2 flag signals. One by one I write. First one, 2 flag signal, because he want 2 flag signal, 2 flag signals. 2 flag signals. See, 2 flag signals. So data is given 5 different flags and number of different signals. That is also very important. That can be generated. Number of different signal means repetition of the digit is not allowed. First box we can fill in how many ways? 5 ways, because 5 different signals. Second box we can fill in how many ways? 4 ways. Second box we can fill in how many ways? 4 ways. So total, according to the fundamental principle, 5 into 4 is how much? 20 ways. 20 ways of different signals contain 2 flags. This is first one. Because at least 2 flags means minimum is 2 flags, maximum is 5 flags. Why it is 5 flags? He has given only 5 flags. Second one, 3 flags signals. 3 flag signals, one below the other. 3 flags signals, one below the other. Correct? So first upper box we can fill in how many ways? 5 ways. Second box we can fill in how many ways? 4 ways. Third box we can fill in how many ways? 3 ways. Total 5 into 4 into 3. 5 into 4, 20. 20 into 3, 60. 60 ways. Correct? 5 into 4, how much? 20. 20 into 3, 60 ways. This is 60 ways we generate 3 flag signals. Because he has not given exactly. In the previous problems, he has given exactly 2 flags. But here he has given signals contains at least 2 flags. Not exactly 2 flags, at least 2 flags. It may be 3 flags, it may be 4 flags, it may be 5 flags also. Third one, 4 flags signals. 4 flag signals. For that, I can fill 4 box. 4 flag signals. So this can be filled in how many ways? 5 ways. Okay, and this can be, second box can be filled in 4 ways. Third box we can fill in 3 ways. Fourth box we can fill in how many ways? 2 ways. Total 5 into 4 into 3 into 2. So 5 into 4, 20, 20 into 3, 60, 60 into 20, 20, 120. 120 ways we generate 4 flag signals. Maximum number is what? 5. So one more we have to write. Fourth one. 5 flags signals. 5 flags signals. For that, 1, 2, 3, 4, 5. This can be filled in 5, 4, 3, 2, 1. Okay, according to the fundamental principle, total 5 into 4 into 3 into 2 into 1. So how much? Again it is how much? 120 ways. 120 ways. So total number of ways, this is very important. Number of ways. This 2 flag signals I call it as event E1. Okay. 3 flag signals I call it as event E2. 4 flag signals I call it as event E3. 5 flag signals I call it as event E4. E2 is not depend upon E1. E3 is not depend upon E2 as well as E1. E4 is not depend upon E3, E2 and E1. Means E1, E2, E3 and E4 are independent events. They are not dependent events. So total number of ways by applying addition rule, not multiplication rule, because all the events E1, E2, E3 and E4, E1, E2, E3 and E4, they are independent events. According to addition rule, total number of ways 20 plus 60 plus 120 plus 120, 120, 120, 240, 240, 240, 300, and total number of ways is how much? 320 ways. Total number of ways is how much? 320 ways. This is very important problem for 3 marks. See, observe the concept. 2 flag signals, 5 into 4. 3 flag signals, 5 into 4 into 3. 4 flag signals, 5 into 4 into 3 into 1. 5 flag signals, 5, 4, 3, 2, 1. Total number of ways by applying addition rule, because all the events E1, E2, E3 and E4 are independent events. That's why we apply addition rule. According to the addition rule, total number of ways 20 plus 60 plus 120 plus 120. The total number of ways is what? 320. Understand the concept? This is very, very important problem for 3-mark question. So we solve the problem. First, you see the concept carefully. Observe the concept carefully. Solution. First one, 2 flag signals. First box can be filled in how many ways? 5 ways. Second box can be filled in 4 ways. Bracket, since repetition of the digit is not allowed. Repetition of the digit is not allowed by fundamental principle of counting. Total 5 into 4, 20 ways. This is for 2 flag signals. Second one, 3 flag signals. First box, same method, first box can be filled in how many ways? 5 ways. Second and third boxes can be filled in how many ways? 4 and 3 ways. Since repetition of the digit is not allowed. Repetition of the digit is not allowed by fundamental principle of counting. Total number of ways 5 into 4 into 3. How much? 60. 5 into 4 into 3. How much? 60. This is for 2 flag signals and this is for 3 flag signals. Next, third one, 2, 3 over 4 flag signals. First box can be filled in how many ways? 5 ways. Since repetition of the digit is not allowed, second, third and fourth boxes can be filled in how many ways? 4, 3 and 2 ways. By fundamental principle of counting, total number of ways 5, 4, 3, 2 is how much? 120 ways. 120 ways. This is for 4 flag signals. 5 flags signals. This is the last one. 5 flags signals. First box, same method, can be filled in how many ways? 5 ways. Since repetition of digit is not allowed. Second, comma, third, fourth and fifth boxes can be filled in how many ways? 4, 3, 2 and 1 ways. By fundamental principle of counting, total number of ways 5 into 4, 3, 2, 1. It is how much? 120 ways. Okay, you can follow any other method also. This is our one method. If you want, you can follow another method. First, you observe the concept 120. Then, this is over. 2 flag signals over. 3 flag signals over. Then 4 flag signals over, 5 flag signals over. Total number of ways according to addition rule. Total number of ways. 2 flag signals is how much? I think 60. 2 flag signals 60. 3 flag signals 120. No, 2 flag signals, not 2 flags, 2 flag signals 5 into 4, sorry. 2 flag signals 20, 3 flag signals 60, 4 flag signals 120, 5 flag signals 120, 320. 5 flag signals 120, 320. Understand? According to the which rule? Addition rule. This last problem for 3 marks, it is very important. This completes the fundamental principle concept. So what we discussed in the previous class, first concept of the permutation and combination is over. Next concept, factorial notations, we discuss in the next class. Thank you.